Hello everyone, welcome to our math class. In this video, we are going to look at inverse relationship and logarithmic equations. Let's get started. In the previous videos, we have learned the exponential form and logarithmic form, and we know they are like opposite operations. It's similar to the relationship between addition and subtraction, and also multiplication and division. Then, by considering the opposite operations, we will see a very interesting result. For example, if we have x and we add 5 to it and then minus 5, the result will be x. It tells us the opposite operations, their effect will be cancelled out. And similarly, if we have x and then it is multiplied by 5 and then divided by 5, the result will be x as well, because the opposite operation, multiplication and division, cancelled out. Now we are going to generalize this idea between exponential form and logarithmic form. We start with the exponential form, and then we have a as a base, x as exponent. Then we are going to apply log on this value with the same base a. Then the result will be x. The exponential form and the logarithmic form, their effects cancelled out. And this result is valid for all real numbers of x. And then, if we are going to start with a log, and then here x is the argument and a is the base, then for the argument, x should always be positive. Then if we are going to convert this one to the exponential form with the whole thing as the exponent, and then the base will be a, then this expression will be simplified to x as well. So it tells us the opposite operations, their effects on x are cancelled out. We can add these two results into the list of logarithmic laws, and it will be very helpful for us to remember all these 10 laws when we deal with logarithmic questions. Now let's focus on the application of these two results. Now let's look at the first example. We have log x to the base 2 equals 5. So the first idea, we can convert this one to the exponential form directly, as x is the base and x is the argument. Therefore, it tells us 2 to the power 5 is equal to x. Therefore, x equals to 32 directly. But in this video, we are going to focus on the method of using the inverse relationship. So first we have the log x to base 2 equals 5. And then we are going to apply the opposite operation to it. Now this one we have log, and then we are going to convert this one to the index of the exponential form with same base 2. We are going to convert both sides into the exponential form. Then on the left part we have log and exponential with the same base. Then it can be simplified to x directly, and the right part we have 2 to the power 5, which is 32. Then let's look at part B. For the following equations, we are going to focus on method 2 only. Then we recognize it is logarithm. Then we are going to use rule 9, and then both sides we are going to convert to the exponential form with the same base. The base is 2. Then to the left part, we will cancel out these two opposite operations, and then the result will be simplified to 2x minus 1 directly, and 2 to the power 4, which is 16. Then we are going to solve for x. It means 2x is equal to 17, which is add 1 to both sides. Therefore, x is equal to 17 over 2 when we divide both sides by number 2. Now we're going to look at this example. Here we have log 27 to the base x is equal to 3 over 2. Then here x is the base, therefore x should be positive and not equal to 1. First idea, we can just convert the logarithmic form to the exponential form. Then the base will still be base, and this one, 3/2, refers to the exponent in the exponential form, and then the result will be 27. As we know, 27 is equal to 3 to the power 3. Then we are going to separate the index 1/2 times 3. Then by comparing them, we know x to the power half is equal to 3. Then it means root x is equal to 3, x is equal to 9. The second idea, we can use the inverse relationship to convert them. First, we have log 27 to the base x, which is equal to 3/2. And then we have the log to the left part. Now we are going to make this one be the index of the exponential form with the same base x. By using the ninth result, now we can see these two values. So these two operations, they can be cancelled out. Therefore, we will have 27 equals x to the power 3/2. Similarly, we will have the value of x equals to 9. You can compare these two methods and find out which one is your preference. That's all for this video, and thank you very much for watching. I'll see you next time.